Hello everyone. The test of significance for single mean. We have seen this topic in last class. Here, test statistic is z is equal to x bar minus mu by sigma by root n. If sigma is standard deviation of population. And the note here is sigma is unknown, then we use the test statistic z is equals to x bar minus mu by s by root n. Here s is standard deviation of the sample. The t can also be written as t distribution is also can be written x bar minus mu by s by root n. The t statistic can be taken only for small sample here, and for large sample we use z here also. Okay, remember it. Here we have the problem. A sample of 900 members has a mean 3.4 centimeters and standard deviation 2.61 centimeters. Is this sample has been taken from a large population on mean 3.25 centimeters and standard deviation 2.61 centimeters. If the population is normal and its mean is unknown, find the 95% fiducial. Fiducial means confidence limits of the true mean. Observe this problem here. A sample of 900 members of mean 3.4 and standard deviation 2.61. Population mean is given 3.25 and standard deviation 2.61. So we have the data from this is sample mean is denoted by x bar, that is 3.4, and standard deviation of the sample is denoted by s, that is equal to 2.61. Population mean is given also, that is denoted by mu, that is 3.25. And the standard deviation of the population is also given, that is sigma 2.61. Now we have to test, is this sample has been taken from a largest population of mean 3.25? That is the question, that is the data we have to test. In this case, we assume the null hypothesis is as there is no difference, means mu equals to 3.25. Alternative hypothesis H1 can be assumed as complementary to the null hypothesis, that is not equals to mu not equals to 3.25. And the level of significance alpha is not given in this problem, so we assume level of significance alpha as 5%, that is equal to 0.05. Here test statistic is given by the formula z is equals to x bar minus mu by sigma by root n. Here x bar is sample mean. What is the value? 3.4. S is 2.61. Mu equals to 3.25. Sigma equal to 2.61. Whereas n is also given sample of 900 members. So sample size is small n equals to 900. So substitute required values in this problem. 3.4 minus 3.25 by sigma 2.61 by root over 900. N value is 900. So we simplify this in this way. got the value 1.73. Therefore, this value indicates calculated value of z. This is calculated value. Now we check tabular value of z for the given level of significance, that is 0.05. But remember, here we use the test is two-tailed test. Look at the graph two-tailed test here. Two-tailed test means the level of significance can be lies on two tails of the given graph. So the level of significance is 0.05, can be split into two parts. It can be 0.025. It lies on two side tails of this graph, that is 0.25, 0.025. Both can be denoted as alpha by 2. Okay. So in this case we have to check z table for the value 0.025. Look at the z table here. Observe the probability, means body part of the z table, the value near to 0.025. This is the value near to 0.025. It can lies on 1.9th row and in the column 0.06th column. So we add these two, that is 1.9 plus 0.06 column gives 1.96. This is tabular value of z for the given level of significance 0.025. Now compare z value and z alpha value here. Z alpha value, z value is 1.73 here, z alpha value is 1.96. Obviously z is less than z alpha. If calculated value is less than tabulated value, obviously we accept the null hypothesis. What we accept the null hypothesis here? The given sample has been taken from population of mean 3.25 centimeters and standard deviation 2.61 centimeters. That is the testing of hypothesis. Now we have the second problem here. Find the confidence interval for 95%. For finding the confidence interval, we have the formula, that is x bar minus z alpha by 2 into standard error, that is sigma by root n, and x bar plus z alpha by 2 into sigma by root n. This is the formula we have to find confidence interval. Here x bar is, what is x bar here? Here x bar is 3.4. X bar is 3.4. Z alpha by 2 or 95%. That is confidence interval. For this confidence interval, we need to find z score or z value. How we find the z score or z value for the given confidence interval can be explained detailed in last video. Please check it. Remember, the steps are: first we have to find level of significance, that is alpha, can be obtained 1 minus 0.95, that is equal to 0.05. Now second point is alpha by 2, because it is alpha by 2 is given in the formula. So 0.05 by 2 is equal to 0.025. Now using z table, we have to check 0.025 in z table. Already find in this here. This gives 1.96. So this is z alpha by 2. So z alpha by 2 equals to 1.96. Now, and n equals to, what is n value? 900. Now substitute the required values in this formula. X bar is 3.4 minus z alpha by 2 is 1.96 into sigma value is sigma, what is sigma value here? 2.61, yes, and n value is 900. 2.61 by root 900 comma 3.4 plus 1.96 into 2.61 by root 900. By simplifying this, 3.4 minus the value of this is 0.17 comma 3.4 plus 0.17, that is equals to 3.23 comma 3.57. This is the confidence interval for 95 percentage. Students, you try 98% confidence interval. This